Hello and welcome. In this video, we're going to learn how to take the derivative when we have the product of two functions. So our goal in this lesson, I can use the product rule to find derivatives. Let's go ahead and jump right in. So we're going to use the product rule. If you want to see the proof for the product rule, which comes from the limit definition of derivatives, you can check out my AP video where I actually work through these proofs. But in this video, we're going to focus on just how do we use the product rule. So if we are multiplying two functions together, there isn't a property that just says we can take the derivative of each of them separately and multiply them together. What this property says, the product rule, is that we're going to take the derivative of the first function and we're going to multiply that by the second function, not changing it, but keeping the second function exactly the same. Then we're going to multiply that by the original first function, not changed, times the derivative of the second function. So I want you to notice we're never multiplying two derivatives together and we're never multiplying two original functions together for this type of problem. So here we're looking at the derivative of the first, and here we're keeping the first the same. Next to it, we're looking at the second, not changing it, and we're going to then multiply by the derivative of the second. We're adding, addition, and multiplication are things that we're used to seeing together. And again, we're not going to go into the foundations of where this property comes from in this video. Our goal is to just be able to use this property. So let's use this property with this example here. So this is going to be my second function. I'm going to use this teal color for that. Here's my first function. So we're multiplying these two things together. And if we are looking at that in the derivative sense, f prime of x is going to be the derivative of the purple piece. If we take the derivative of the purple piece using the product rule, this 2 is going to multiply by the 3 to give us 6x. This negative 2, that derivative is going to be 0. So the derivative of the purple term is just going to be 6x. We're going to keep the blue term or the teal term the same here. And then we're going to add, now we're going to keep the first term or the first function the same, and we're going to multiply that by the derivative of the second. The derivative of this is 2, the derivative of 3 is 0. Now we're just going to clean this up by distributing. So 6x times 2x is 12x squared. 6x times 3 is 18x. If I distribute this 2 plus 6x squared minus 4, and then let's go ahead and combine like terms. We're going to get 18x squared plus 18x minus 4. Now, something I want to point out about this particular function, this is just two binomials being multiplied together. So if we didn't want to use the product rule, we could actually expand f of x first before we take the derivative. So if I multiply 3x squared by 2x, I would get 6x to the third. If I multiply 3x squared by 3, I would get plus 9x squared minus 4x minus 6. And then I could just take the derivative using the power rule. So drop this 3 down. 6 times 3 is 18x squared. 9 times 2 is plus 18x minus 4. And notice we get the exact same answer here. Now, this won't always work. We won't always be able to expand because if we had trig or something that wasn't a polynomial, we wouldn't be able to use this particular approach. But keep in mind, the things that you have learned before this lesson, they still apply. So use them to your benefit if you see something that's going to make the problem easier. Let's look at some more examples. All right, here we go. Let's identify our two functions again. So on number 1, our first function is going to be x squared, and our second function is going to be cosine of x. And I can tell I'm going to use the product rule because these two functions are being multiplied together. So f prime of x is going to be the derivative of the purple function, which is 2x, times keep the teal function the same, plus keep the purple function the same, and multiply by the derivative of the teal function. And I'm going to just clean this up slightly. 2x cosine of x. I'm going to move that negative in front, so minus x squared sine of x. And there we have our derivative. Now remember, for problems like number 2, it's going to be easier to work with the derivatives if you rewrite these using rational exponents. So I'm going to rewrite this as x to the power of 2/3 times x cubed minus 1. You could expand this or distribute this, and then you wouldn't need to use the product rule. But since I want to really focus on making sure we understand how to use the product rule, I'm going to leave it like this, and I'm going to identify my purple function and my teal function. So if I take the derivative, f prime of x is going to be the derivative of the purple function, 2/3 times x to the 2/3 minus 1, which is going to be negative 1/3, times x cubed minus 1, plus keep the purple function the same and multiply by the derivative of the teal function, which is going to be 3x squared. And we could combine this to make it a little simpler. We could combine our x's, but we're just going to leave it like this because I really just want to focus on working through the product rule here. Let's look at a couple more examples using the product rule. Now for number 3 here, this looks like a quotient, not a product, but I want to remind you that you could rewrite this as sine of x times x to the power of negative 1/2, and then we have a product, and we can identify our first function and our second function. Similarly for number 4, it's already set up so that we can see our first and second function. And even though I could expand on number 4, I could multiply those two polynomials out. That feels like a lot of extra algebra, and I actually think the product rule is going to be easier here. So I'm going to encourage you to pause the video and work through the product rule on numbers 3 and 4 on your own, and then unpause the video and see how you did. So here on number 3, I got cosine as my derivative of sine, and I got negative 1/2 x to the negative 3/2 as my derivative of my teal term. And when I rewrote it, I just put the trig term second. I think it's easier to look at. It's less confusing as what we're taking sine or cosine of. And then here on number 4, the derivative of the purple function is going to be 2x plus 4, keep the teal function the same, plus keep the purple function the same, and take the derivative of the teal function, which is going to be 3x squared. I don't see any reason to expand that out and combine like terms on this particular problem, but if you did that, that's great practice with your algebra. We're going to look at 2 more problems, one a little bit more challenging abstract problem, and then one that we're going to build on what we learned from the previous lessons, and then we'll go ahead and wrap up this video. All right, so here we're given information about f of 2, f prime of 2, g of x, and we're being asked to find g prime of 2. So let's start by looking at what is g of x, and then let's go ahead and use the product rule to find g prime of x. So here's my first function, and here's my second function. I'm going to work through this derivative part in the same way that I did before. So g prime of x is going to be 2x times, keep the second function the same, so f of x, plus keep the first function the same and multiply by the derivative of the second, which is just going to be f prime of x. I'm going to encourage you to now pause the video and see if you can plug in the numbers and figure out what g prime of 2 is. Then unpause the video and see how you did. So we can plug in 2 for all of our x's, and then we can look up to our original problem when we need f of 2 and when we need f prime of 2. And when we simplify this down, we're going to get that g prime of 2 is equal to 8. All right, one last problem. So the whole point of being able to find the slope or the derivative is so that we can write tangent lines. So let's extend this idea. We're given a function that has a product within it, and we're going to be asked to write the equation of the tangent line to the given function f that passes through the point 3, 20. So what I want you to do is go ahead and pause the video, find the derivative, figure out what the derivative is when x is equal to 3 so that you can write the equation of your tangent line. Then unpause the video and see how you did. All right, so here's our first function, here's our second function. If we find the derivative, f prime of x, the derivative of this whole purple part is just 1. Keep the teal function the same, plus keep the purple function the same, take the derivative of the teal function. So this is going to be x squared minus 5 plus, I'm going to go ahead and distribute here, 2x squared plus 4x. I'm actually going to just go ahead and simplify this one more step. I'm going to combine like terms. 2x squared and x squared is 3x squared plus 4x minus 5. And now I can just plug in 3. So 3 times 3 squared, which is going to be 27, plus 4 times 3, which is going to be 12, minus 5. That's going to give us 39 minus 5. That's going to be 34. This is our slope. To write the equation of a line, we need a point and a slope. So I'm going to put TL for tangent line here. Y minus the y value of the point is going to equal to x, is going to equal the slope times x minus the x value of the point. Well, the slope we just figured out is 34. And if we look at this point here, the x value is 3 and the y value is 20. And there we have the equation of our tangent line. Let's go ahead and wrap up this video. All right, our goal in this video was that we could use the product rule to find derivatives of functions that involve two function pieces being multiplied together. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.